Oh, but then we have to stop. Oh.
Yeah? Oops. Echo? Should I stop sharing here? Okay. How can I switch the monitor so it actually displays?
What do you want to switch?
Here.
To your monitor. Yes, which
No.
cable was this one? Oh yeah, sorry. And you should be.
No. Plug it in again. No, it seems to do something. Yep.
All right.
It was a cable thing. Okay. Are we good?
Well, it's not going to be in the live stream because you need to open StreamYard. Do you have a long presentation? Otherwise, we need to send you a link.
No, I'm already on StreamYard. Feedback of like what you liked and didn't like about the meetup, and this like in these like adjusted environments. My name is Bastian. I started this meetup around 3 years ago. I am a co-hosted this with Ryan in the past few years, and now we try to start to keep the ball like rolling again. In the background, all the work was done this time by all like the tech team, by Prisma, and especially by Natalia, who couldn't be here today, but she did all the organizational part and stuff. So thank you so much to Prisma and to Natalia for having us. And feel free to text me on Twitter, like what you didn't like, if you want to have a talk in the future and stuff like this. This meetup, I started this because I wanted to have a space in the city just to share like a learning process about Rust. This meetup is not meant for finished projects. It can be, but it can also be, I talked to a few people who come from the front end or from the .NET world. Feel free to come here and share your thoughts about Rust. You don't have to show like a working code examples. You can just come and say, I come from .NET and I don't like Rust, and here's why. And that's perfectly fine. And I feel like, this space is meant to share the learning experience. If you feel like the talk, like the quality is too low for you, I think this is sometimes, like intended. So please don't bully the speakers for the code choices that they made. This is just an open space to share our process, which also means we follow the code of conduct, have a read. We try to be nice. This is all our free time here. So like, just be nice. And if you don't like it here, try to text me on Twitter and tell me like what you didn't like. But yeah. So like the format in the coming years, like it changed a bit, but like the core was always that we have 3 different the speakers, they have each a slot from 20 to 30 minutes, sometimes 40, sometimes 10, it depends. We have a break after each of the speakers today because we do like a live stream too, and we need the mic changes. We have like the catering, which you saw outside. We follow the 3 Gs, so you need to be tested, or I don't know the English words. It's probably like the 3 Gs are probably like a German way of saying it. But sorry, I didn't even. Yeah, so yeah, just like the usual stuff, like have a test, be recovered, or be like vaccinated. And just feel free to hang out and chat. I was told that we have to leave probably like the premises by around 9 today. So if you want to hang out for much longer, feel free to grab a group and go to a pub or talk on the street. Yeah. This being said, am I touching something? No? This is very complicated today. Can we change? Is there a... Yeah, with the like the
remote.
maybe I'm
The remote.
maybe I'm
I
like
think I have it in my pocket.
Okay, thank you. So, which means that and I said it in the beginning, please feel free to submit a talk. And sometimes you see this meetup and you see these amazing people in front of you, and you think they can do I don't know, so much more than you. But they also started out at some point. So just please feel free to step up and to submit a talk. It can be like a shitty talk. It can be a short talk. Just feel free to use this space to share your thoughts about Rust. We have 3 speakers today, 3 talks today. Like the first one is from Zeeshan about async await. Then I give a talk since there was not enough talks, so I have to give a talk too. It's about a good tutorial to learn about the language. And then we have a talk from Michał about how to develop and manage eBPF programs with Rust. And we have a special guest today, which will come on stage shortly now. And yeah, she can say a few words about something.
Hi, I'm Anki. Oh, that's good. Some of you might know the last version, the last release of Rust was dedicated to my daughter Anna. Anna passed away 2 months ago after long illness, and I just wanted to come here. Sorry to drag down the mood. I will go away immediately. I just really wanted to say thank you to the community for this gesture. It was so nice. And the Rust meetup that we went to 3 years ago at Mozilla was really the only time that Anna really was able to go out anywhere and talk about her interest with actual people before then the illness hit. And it meant a lot. And this gesture meant a lot. Sorry about that. I just really wanted to say thank you. So have a nice evening. Cheers.
Well, thank you so much for coming on stage and take like your time here. I think this also shows like why we do this, just for people and not for the technology behind it per se. So thank you all for coming, and I welcome our first speaker on stage. Thank you.
Hello, everyone. My name is Zeeshan Ali, and yeah, I'll be your first presenter. Bastian asked me for if I can do a talk last week, so I didn't get a lot of time to prepare this, and this is the first time I'm presenting this talk, so I'm sorry if there's any mistakes. And also I have to admit that I had to borrow a lot of things from tutorials and books and stuff. So yeah. First of all, who am I? Like, short introduction for those who still don't know me. I keep coming here, so you should know me. Anyway, I've been living in different countries, so I'm a bit of a nomad. And I work for a company called MyData. I just started last month, so don't ask me a lot of questions about what we do. I'm still figuring that out. But what I know is that we provide extremely efficient, I wouldn't say high, but extremely efficient storage to the cloud, to Kubernetes clusters through a mega project called OpenEBS. My job is to look at a specific project, a relatively new project in that space called Maestro. So that's my job, and I've been involved in the FOSS community for a long time now, my background was with GNOME and other, mostly Linux, embedded and desktop environment development. I love planes and helicopters. I had a helicopter license that I lost because of slow German bureaucracy, but I do have a plane license that I got in Germany, so I'm more or less thankful for that. And I love cats. I'm also a member of Async Foundation's working group in Rust. I don't know how I became part of it, but somehow I did. But I did contribute a bit, not recently, but for a while I did. So let's get into it. Like, what am I talking about? First of all, what is it with async? Why async? It's basically about concurrent programming. When I say concurrent programming, first question that people would ask, why not just use threads? And yeah, you can use that. And also Rust has libraries in the standard library for that. You can do that certainly, but it depends on your use case, right? Threads do have an overhead, so you have to ask yourself, like, is your workloads there CPU bound, or are they more IO bound? Because if they're IO bound, you mostly spend time waiting, and if you just want to wait, you don't want like lots of threads launched just to wait, because threads, as I said, have an overhead, especially if you are on a low resource or resource constraint in any way environment, such as embedded systems, then it's especially true. And also, like, it gives you the look and feel of doing normal synchronous programming. So in here, if you notice, these are simple examples also, but it's just the same as it would be without async, except that you're declaring the functions async, and when you call them, you await for them, and that's the only two differences you will see here. But we will get into the detail of how this is working and stuff in a bit. Then you say you wrote that code that I just showed, and then you want to call that one of the functions, and you do it like this, right? Or at least you would think so. And then if you write that code, it builds and it runs successfully, no warnings whatsoever. However, it wouldn't print anything, even though there were print statements there. So why on earth would it not print anything? That doesn't make any sense, right? And if you look at the code, the error that you will get from the compiler, like, it's not an error, sorry, it's warning. Sorry, I said that you will not get a warning, which I was wrong, because that would be really bad if you didn't get a warning either. But at least you get a warning from Rust. You get a warning that future is not used, and what the hell is a future, and what is this await, and what is polling? What does it even mean, like this whole error, right? If you're new to it, that's what you will think. The main thing that you need to know first is async functions. They return in reality, behind the scene, a future type, and future is a trait in Rust. It's I always dream of seeing the future, so I wanted to show you the future. And just like the dog, you wouldn't actually like to see the future when you see it. It looks like this. If you mainly focus on the type part, the associated type of output, it's then becomes pretty simple to see it. It's a type that you can ask for an output from. It does have any processing needed or whatever to produce that output, and you call basically poll on it continuously until it yields that output. And you can there's an enum poll in the standard library for that. So if it still can't produce that output, it will say that it's pending. So a future has two states: either it's pending or it's completed. When it's completed, it's already, you would call it. You will get your output back. This is what I just mentioned is suffice for now, but we will look into more later. So behind the scene, when you desugar it, like the compiler is handling the async part for you, but it changes it into something like this. It's actually a simple function that like you normally have, not async, but it returns something that implements the future trait that you just saw. And the return type that you declared for your async becomes the output type of this future. And these futures are inert. So that's why when there was this warning that you're not using the future. You created the future. So the async function that you called, it gave you a future, but you didn't wait for it. You didn't poll it to completion. So that's why it didn't actually do anything. You just got the output. So we need an entry point to make use of this future that the async function is returning, right? So let's await the future. That's what the warning suggested, right? Like in the warning, it said like you have to wait for it. So let's do that. So in the main function, you call the same and then just add .await. I want to wait for it, but computer says no, because async is only allowed. That is the error you will get inside async functions and blocks. So how do we handle this? Enter runtimes. Like you in Rust, you have something called runtimes, and it's not built into the standard library. It's not, at least right now, and I don't think it will be. And they are external. For many reasons, it was thought that it should be kept external, and people can provide it with different solutions for it. There are multiple runtimes available out there. There's single-threaded, multiple-threaded. Single-threaded one is like if you have a resource, as I mentioned, resource-constrained environment, you don't want multiple threads launching, especially behind your back without you knowing. So in those ones, you will use single-threaded runtimes. But if you don't care, if you want things to be, working as fast as they could be on your system, then you would probably want to use a multi-threaded runtime. And it's typically much easier to use a multi-threaded one. A single-threaded has some constraint on it. And the most common ones are Tokyo and async std, or async std, however you pronounce it. And for the purpose of this talk, I chose async std because frankly, it just doesn't get enough advertisement as much as Tokyo does. So I thought I'll give them some advertisement. Although nothing against Tokyo, I use Tokyo as well. So yeah, what we do, we use something called block on. Actually, every runtime that I have seen provides this function with the same name, with the same semantics and behavior. So you use that block on, and you give it a future, and it synchronously keeps polling it until it's complete, and it gives you the result. So that's how you will use it, for example. And if you remember in the error I showed, it also talked about async blocks. It wasn't just saying async functions. So what are async blocks? You can actually create a future, anonymous future, just on the fly, just like you can create, functions in anonymous functions in Rust. You can also create anonymous futures just on the fly, and you can do it this way, for example. And you can use it just like any other future. But so far, what we have seen, you just keep waiting for things. So that's not really concurrency if you are just waiting for each thing separately, right? And one of the ways of achieving concurrency with async is spawning and tasks, spawning tasks. And actually, from what I know, also all the runtimes that I've seen, they call it a task. So maybe there's a runtime that calls it differently. So you have in Tokyo as well a task, and also in small as well, and in async std as well. So you spawn it, and it just takes a future, and it just spawned for you. In some runtimes, you have to specifically detach it. So detach means like just run it in the background. I don't care anymore. But in async std, it's the default. Like if you don't keep the return value of spawn, that task is then detached for you automatically, which is very useful, I think. So in here, it will just run those two, and then you can just sleep or do what other things, and those tasks are running in the background for you. When it completes, it just goes away on its own. But tasks themselves are also futures. They implement the future trait, which is really cool thing about Rust. Like with the traits, you can add behavior to so many things, like your own types and stuff. So since future is implemented for task, you can use it as such. You can wait for it. You can do other things that we will see later. So, for example, combining futures, right? So, for example, you can. There's a crate called futures, which is actually maintained and written by Rust developers and so like it's under the Rust Lang GitHub space. So it's quite officially, it's almost like std, but it's not std yet. So, and a lot of these API that exists in futures crate, it's planned to go into std at some point. I think all of it, but I'm not so sure about that. But at least most of it will go at some point into std in some shape. So anyway, so it's more like a proving ground. And there's one method there called join, and you can join multiple. It's actually a macro, so you can give it many different futures at the same time, and it waits for them at the same time, like all of them. And as soon as all of them are completed, it returns. So you can concurrently wait for tasks, which is what you want when your tasks are IO bound. As I said, like most of the time, what you're doing is waiting for something to happen, waiting for data to be available and stuff. So you just want to concurrently wait for events, and that's what you do here. And you have other goodies in futures crate as well for futures, like you can select on them instead of joining them. You can wait for either any of them completing. So if you just want any of them completing, that's what you would use. You select on it. Or you can map them. So as I said, like, every future has an output. So if you want to modify the output some way and create a future out of it, so you can just call .map and then map just like you do with results and options and stuff. There's a concept called streams. So in future, you had one output. You consume the future, you poll it, and it completes, and you get output, and that's the end of the story. But with streams, you keep getting it. You can keep getting output until it's depleted, for example. And they're sort of like async version of iterators. Actually, when it will get into std, the streams, most likely it will be renamed to async iterator, the stream type trait. So how do you use it? For a simple example, you just you have some helpers in futures crate that you can create futures out of some synchronous code, and streams, also futures, but streams as well. And in here we have something called repeat. You just give it some value, and it just repeats it. So the stream, each time you call next on it, just like you call next on iterator, you call it on the stream, but it's async, so you have to await it, and it will becomes it just keeps giving you values. As I said, similar API to iterator, like there's a lot of helpers available in future, and other also provided by the runtimes. Different runtimes provide nice goodies. But as I'm explaining async, and it's all cool and stuff, there's currently some limitations as well. And one of them is async traits are not possible. By async traits, I mean traits with async functions. And why is it not possible? Because Rust is supposed to be zero cost, the main APIs at least. And this is not possible right now. It's not possible with the current Rust implement, Rust, all the features of Rust. It's not possible to implement it so that you can have, you can implement it with zero cost. You have to allocate to make async functions and traits possible. But worry not, you have nice trait called async, nice crate called async trait, and that you just use it like. Do I have an example here? Yes. So you just use it. It provides you with a macro, attribute macro that you use it on your normal looking trait, and then you can just do async fn. And in the reality, in the background, it's doing allocation. So as long as you're okay with that cost, you can just use this, and it's fine and it works. Similarly, for the same reasons, as far as I know, you can't have async closures. So you have to do something a bit complex. In here, you have a call that just takes a callback to call async callback, and just like you will define a callback in a generic way, you tell it it's a function which doesn't take any input, but it produces an output. But the output is a future, and that future has to implement the future trait with the output that you need, and that's how you'll use it. And then we use it. We call, and we just pass it a async. Like we pass it a callback that just creates an async block which implements future, so you can use it like that. And you have one of the problems of having runtimes external to standard library is that it's not really possible to write. Well, it's possible, but with a lot of hard work. I know from my own experience, I've been implementing an async API for the last many months that needs to be, or I want it to be agnostic of async runtimes out there. And it's super difficult. There's a lot of problems that you need to solve to achieve that. It depends also, like some simple things are very much possible, like you can provide a agnostic library, but a bit more complex where you have to read from sockets and transform what you read from sockets and stuff like that, then it's quite hard. And also you have like some small problems that can become big problems if you encounter them. And one of them is called async sandwich, sort of, where you call async. You call basically you call async from a synchronous from a async. So you have a sandwich. So you decided to run a runtime to run a future, but in that future down the line in the chain, it's right here. It's right directly under it. But in reality, you would encounter this problem where down the chain where you're calling a lot of functions, somewhere there you call a blocking function, a synchronous function, and that uses block on to run some synchronous async work. And then you have a problem because this can cause deadlocks. You can't run runtimes within runtimes. And actually, if you do it with Tokyo, purely with Tokyo block on, both inside and outside, you will get an actual runtime error. So that's a problem. But rest assured, the async working group knows all about all these issues. They have been informed, and they are working on solutions, proposing solutions to the greater Rust community, and also to STD maintainers and authors. So yeah, that was a very quick introduction to async. So I'm sorry if I went very fast, but if there's any questions, I can answer. Yes.
Can you say a little bit more about how you approach building agnostic libraries?
So one helper that you do have is a bunch of crates written by someone called Stepan. He moved on from Rust a while ago, and he wrote this set of libraries. He actually wrote a runtime, very small runtime called Small, SMOL, and that was divided into really small, tiny subcrates that have different functionality, like async locks. If you need asynchronous mutex or read-write lock or something like that, so you will use that crate, and it only provides that, right? And async channels. You want channels that are async friendly, works very well with asynchronous code. You use that. So those set of crates really help you out, but they go as not far enough, like you really. And also, like when he was going away, he said, "And who wants to maintain my project?" So I volunteered because I was depending on it so much. So I'm one of the co-maintainers now somehow. One of the things that wasn't there was async broadcast. Like there's async channels already, but there was async broadcast was missing. But he had a work in progress crate for that. So I picked that up with Yosh's help, and we finished that, and it's now published. And I actually actively maintain that because that's mostly my code now. Anyway, so you have that as well, broadcast. So there's a lot of those kind of crates, and also, like, if you're okay with it, Tokyo does make it possible to use only subset of their crate. So you can, if you just need, for example, as I mentioned, locks, you can just enable that. You can disable all features, all default features, and you just enable the channels feature, and then or locks, and then you only have a crate that you're using that only has that. So that helps. But there are some problems that are not solved in a way that is agnostic to async. One of the ways that I did, like, I needed someone to continue, like, I had some task internal in the crate that needed to be run, right? How do I do that without using a runtime? And so I provided, with this help of the small, there's a async executor, and I just run that inside, but you have an option to run it yourself. So if you want to integrate it with your runtime very well, you can do that, or you can use the default, which is I launch a thread and I just run it behind your back, but it's just one thread, so it's not that bad. But I had to bite the bullet and run this thread because there was no other choice. Yeah, sorry, you asked for a lot of details, so I am giving, but we can talk later about it.
Another question.
You had some.
Yeah, I wanted to know how do you choose, like, between the runtimes? Like, what is your criteria, like which runtime to choose for a project?
That's not as easy a question as you would think, because people are very opinionated about it. Like we in the async working group, we were talking about, like, an example of a story. We came up with a story of someone wanting to move from Tokyo to async state, for example, and we came up with reasons why would they do that. But then the Tokyo guys came and like, no, that's not true. You can do this with Tokyo and you can do that. So it's a bit yeah. But I would say that try both, see which one works best for you, because there are different APIs. There's some APIs for some use cases in async STD are much better to use and easier to use for some use cases. But then the Tokyo ones are a lot better in terms of, like, they're very generic. So if you have generic problems, Tokyo usually works. But when you have some specific problems, that's my experience. I might be completely wrong about it, but that's my experience. That for specific use cases, async STD usually is the one you go to. Yeah. No. Oh.
Could you speak into this thing, please?
Are we async yet?
What?
Are we async yet?
Not really yet. We are working on it.
Maybe pass it on to the next one if there's one.
Don't be shy. I don't bite. Yeah.
Thank you so much.
I'll take it to the front, please.
Do we have a Prisma person now wanting to talk?
For you today. So Prisma is a next generation ORM for Node and TypeScript. And as a developer, it can make your life a lot easier by facilitating how you access data from the database. So typically in application development, interacting with databases, particularly relational databases, can be a huge bottleneck. And Prisma kind of gets around this by providing a type-safe API that returns plain JavaScript objects. So currently we support MySQL, Postgres, SQL Server, SQLite, and Mongo. So what is Prisma more specifically? Well, it's a whole tool chain, but our three core products are Prisma Client, Prisma Migrate, and Prisma Studio. So Prisma Client is this type-safe API that you use to interact with your database. Prisma Migrate is a database migration tool that makes updating your database when your schema changes a breeze. And Prisma Studio is a modern graphical user interface. So at the heart of these technologies is something called the Prisma schema file. And this it really unifies all of these technologies as it acts as a single source of truth between your application data and your database models. So Prisma Client uses this Prisma schema file in order to generate the type-safe API, and Prisma Migrate also uses this same file to generate SQL migrations for you. So the two main benefits of using Prisma are higher developer productivity and higher developer confidence. So using a tool like Migrate, you can move a lot faster because you no longer have to write SQL migrations by hand. You can basically just run npx Prisma Migrate, and then SQL migration will be generated for you. You can also have a lot more confidence as a developer because the type-safe API that Prisma Client provides to you allows you to discover which models, what fields, what operations are available to you before even running a query. So right inside your IDE, which is awesome. This is what a typical Prisma Client query looks like. This is going to make a request to the database that fetches multiple post records. It's only going to take the ones where published is set to true. It's going to skip the first 10 and only take the next 10, so rows 11 to 20. And then it's going to order the return alphabetically by the title. So this looks really awesome. It's a nice, clean API to work with. I think the real magic of Prisma can be felt when you're actually writing this out, because you'll get autocomplete and you'll be able to see exactly whether it's valid before ever running it. So, and one last thing about Prisma is that it's technology agnostic in the sense that it works with any kind of API. So you can use it with a gRPC API, a GraphQL API, or a REST API. And that's everything for me. My coworker, yeah, Martin will. Oh yeah, there's not usually questions, but if anyone has questions, like it's very short. Yeah, sure.
Cool. I'm not going to bother too much with putting this on. So. My name is Martin. I also work at Prisma. I help with some recruitment efforts. I just quickly wanted to shamelessly advertise some people that we're looking to hire. Maybe we can skip to the next slide. If anybody's in control of the laptop. Am I supposed to do it? I am. Cool. So quite simply, I tried to find something that might actually be relevant or interesting to all of you, considering the nature of this meetup. So as Emily was just discussing, most of the work we've done up until now has been open source, but Prisma is sort of leaning into a commercial offering that we're busy exploring at the moment, and we're putting some teams together to start building that. More specifically, we've put a team together called the Scale team, which currently has 3 members, 2 Jacobs, which is not confusing at all, and 1 product manager, sort of based in Dublin, Poland, and Gran Canaria. What they're busy building is the Prisma data platform. I am not an engineer, so I'm going to just read what's written there. So what you'll be working on if you do decide to join the team is building some reverse proxies and HTTP services and a lot of other things according to them. It's generally a greenfield project, so there's lots of space for like exploring new things along with Jacob and Alberto. Yeah, and generally quite a good bunch of people to work with. We use Rust, but we don't see it as a requirement that you be an expert at it. Only an interest in it is good enough for us. So we realize that lots of people are getting into Rust in the time as it's becoming more popular and a more sort of production level code. And apart from that, we also work from anywhere. So the team is generally based in Europe. So we try not to have people too far away, like West Coast of the US would be a bit intense for them. But yeah, if you're interested in talking about that, I'm not the person to talk to about engineering, but happy to talk to you if you want to know a bit more about the company. There are some engineers floating about. There's Emily, and there at the back is Julius and Tom, and Joel is also usually by the door, tall guy. Yeah, so feel free to talk to them if you want to know a little bit about that. They will know much more than I do. Apart from that, might be less interesting, but also things that might apply to you is there's a bunch of other positions that are open in TypeScript, and we're looking for an engineering manager, senior developer advocate, and an enterprise architect, which is a little bit further perhaps removed from more Rust related work. But if you perhaps know anybody, or if you're interested in any of those things, please feel free to go check on the job board, come talk to us. Yeah, happy to do that and spend some time. Cool. Thank you very much for your time, and thank you for attending. I appreciate it.
title is a bit catchy. But in the past, so I did some little side projects over the last a few months, just some little helpers, and I figure out this might be a nice way of actually like learning the language. So I created like a little repository and have some guides, 12 or 13 steps. And this is what I'm gonna present to you today. So my name is Bastian. I created this meetup in the past 3 years ago, or I started this meetup 3 years ago. I worked as a Rust engineer at a company called Kraken, the digital currency exchange, or people in the blockchain world might know about it. And I was part in the past of the Async working group. And now I work as a solutions architect at a company called Twilio. It's a communications platform where you can send text messages, voice, and video, email through their platform. So if you get a text message from like Netflix or your cab driver company, this most likely comes from Twilio. And I also currently write a book, like with Manning, called Rust Web Development. You can pre-order this book. It's not out yet. It's about 60% done. I hope I finish it by the end of the year. And this book is meant, as you just heard, that Prisma is looking for like Rust developers. This book, if you have, can wait a little bit longer, is a great way of picking up the language in a web context. So if you try to apply for a company in the future, this book is tailored towards people who want to pick up the language and do some practical project. So I'm not like a language guy, I'm more like a practical person. So this book is towards people who want to have like a hands-on experience. So like you won't learn from this book the best way of like writing like Rust code, but you learn how to deploy and develop code like with the language. And for also, if you work in a company and you want to onboard Rust developers, this might be a good book to hand out to your employees. Oh yeah, and there is like a website, obviously, like you can buy the book, but there's also like a website called rustwebdevelopment.com. I try to write in the future little blog posts about it, so you can like learn piece by piece. But now about the talk. This is about the one tutorial. This is on, and I'll show like the website later. So this is meant like I scratched an own itch where I'm a freelancer, or like I was mostly like a freelancer for the past 5-6 years. As a freelancer, you don't pay into the retirement fund per se, so you have to handle like your own money. And as it goes, like with like developers, like you have like different income streams through like investments. I just centralize them all into like a Google Sheet, but I don't want to constantly update them. And it's also like important for me to know how long does my money last until I run out, like when do I need to look like for a new project. So I built like a Google Sheet which collects all these different price points from different endpoints and updates the sheets and sends me an email each Sunday with the latest stats, like when do you run out of money and how was the week. And like I'm through the process of having this small tool, I thought this is actually quite nice. Since I cross like a lot of topics you would cross in a bigger project, but the code base is so small that it's easier to reason about the problems and it's easier to fix them. And therefore I thought, like let's form this into a tutorial. This being said, this might be not your jam, like you might be not into finance or something, but I find this is also great. Like for example, I have like my read it later list. You can build like a cron job which goes through your pocket list and deletes the articles which are older than 2 weeks. So like this forces you like to actually like read the stuff you save. So this can be adjusted, and I go after the talk or after like the last slide to talk a bit about how you can adjust this. So here, like you say, like it's about or here you can see this is about 399 lines of code. It's like 8 files. You can do this much simpler. but I fleshed it out a bit to touch a bit of more broader topics. So you actually face some troubles you might have to fix, which then you can learn about traits or like logging and all of this stuff. And like the nice part is, since I'm not a person who wants to learn a language for the language sake, I try to build stuff and I don't care about like the language. But this is nice instead of building the 10th to-do app or like something else. Like it's nice to have something in production yourself, or like in production means on your own server or like a like a digital ocean instance or something like this. So this is the tutorial. It's 13 steps, and you don't have to read through like the whole of it. Since I worked in the past at a crypto company, I'm interested in some cryptocurrencies. So like this is why this is tailored towards this stuff. So this is basically like you start with an HTTP like a request, and then each step is building out a bigger and bigger and more like useful application. So like first, like you just send out like an asynchronous HTTP GET request. Then you try to actually fetch something from an API. Instead of hard coding the API key, try to put it in an environment file. Then print it out like nicely on the command line. Instead of hard coding this, try to have like a CLI application to pass the arguments for your API call. Then you can save this in a CSV file. If the GET request returns something you don't like, try to build your own error handling and like a logging mechanism. In addition to crypto, add another HTTP request to an ETF. And then this is also obviously up to you. Try to store this information or update this in a Google Sheet. And then you have like a nice amount of lines of code. Like you might have maybe 200 lines of code. And now it's interesting, how would you split this up? And you wouldn't do this if you build this for yourself, but it's a nice way, because it's a little, I don't know, like an application of 200 lines. It might be even simpler just to keep this in one file. But it's a nice training. Try to figure out how would you split up this code and learn how to work with different, like modules. And then since I have like a very cheap server instance, I try to build this code onto the server, but the building each iteration of the code took like 2 minutes or 5 minutes sometimes. And then I figured, why don't I just compile this on my machine and try to push it onto the server? And then of course you have a problem with this doesn't like run if you compile it on a Mac or on like a different like Linux distribution. You have to figure out how to cross compile a binary, which is interesting too. And then in the end, you can send out an email to yourself with all the overview you just saved, which means you also learn how to send an email from Rust code, which I think is quite interesting. I want to go into like a few highlights. So like this talk is not super structured. I just want to try to touch on a few things. And for, I think like a few people are completely new to the language, or they try to learn the language. So I think it's quite nice to go through some of these topics. And so you can find the repository under this, like I use sr.ht for my Git repositories. And that's the tutorial. I have the solutions. I tried to write like more text, but I just became a father for the second time like 4 weeks ago, and I definitely don't have time to do much stuff. So I try to fill this out like with a bit of interesting topics you might face and how to solve them. But each of the steps have their own branch. So if you click on this, you actually see like the code. And the log file is in here too, which I shouldn't have done. But here, like you can go there and see the result. And if you go to like the second step, so for example, in the previous talk, we talked about, or there was the topic about, like runtimes and asynchronous code. And here you see, and this is basically a copy paste from the library from like request, which uses the Tokyo, like runtime in the past. The nice part about this tutorial is, since in the end it's 399 lines of code, what if you change the Tokyo like runtime to like a different one? And like what would be the what would be the impact of the change? And I feel like in this amount of code, it's actually quite nice to try something out. So like with this code base, in the end, you can use this in your job when your colleague says, but I use this library for this case. You have like a running code base to try this out, to try new like runtimes out or new libraries out. So this is how an HTTP request would look like with the library called like request. I think it's quite nice to also see from people from other languages that it's quite nice that you can just do like a .json, and then you have like a JSON structure. In this case, we pass, or like we assume that this is a hash map of a string, and if we open this in the browser, it's pretty simple to see this structure. It's a string and a string in a map. And we come to this later in the second step. We do, hey, let's fetch something real from this API. And then the question is, how do you structure this in your code base? So if you go, for example, if you check out step 2, I hope I still have my, nope. Let's see. Or I just copy paste this later. Okay. For example, if you would run this now, and we see here, I usually don't work on a MacBook, so it might be a bit slower to handle this stuff. I think this has everything we need. You can see the API key. It's a no. Nope. Okay. Sorry. Again, I prepared this whole talk on another machine. Bear with me real quick. This is just a trial API key. So I can just copy this key and then put it in here. Nope. So the nice part is what I want to show you is how would you go about in your first step to integrate an API. Let's say your company wants you to fetch some information, you read through the documentation, and like what is your next step? Yeah. I think here works too. Let's get this in here. You see my API key. So like, what would you do like with this information? Like you need to build an application and then you get a whole amount of text back. And here you see it's building. And then you get a whole amount of like wall of text back. And how would you go about to figure out how to build your structs and stuff like this out of this mess? And a nice tool for this, I don't have it here. There's like a website called transform.tools, and you can pass your JSON and it spits out your Rust structs, which is quite nice. And I think this is not valid JSON, so I don't know how I tried it in the past. Yep. Let me see. What you can do is then obviously if this is not just with this might be it. Nice. Beautiful. And then you can paste this here and boom, you have your structs. So this is quite nice. And with Rust, you don't need to do this. So for example, in this example application, I don't care about the status. And you see like what is the status? I don't know where here, like all of this stuff, I don't care in this case. So it's important to know that you don't have to have the field for every return you get. Okay, I can't do this, and we can move to step 3. Nope. Let's say step 4. Here you see that I just have like a data, and the data is a hash map of a string. And I'm not interested in all of the fields this API is giving me back. So like you don't have to, for example, in Rust, you have the option type, I think. For example, like where you say option and then, I don't know, string or something else. And you don't have to do this. Like you can just say, I don't care, and that's fine. And all of these steps, and I don't want to spoil this too much for you, but all of these steps, I feel like they will help you, since if you join as a new Rust developer in a company, there's so much, I don't know, like new stuff, that these little things should be in your, I don't know, like muscle memory, because this will help you later on just to do the actual task and not to think, how should I do this in Rust? And I feel like this tutorial covers all those basics. We, for example, see like if we want to print this now. So we have now like a currency. We get this from a hash map, which is this, for example, and we want to print out this currency, since in the tutorial it says get the name, the symbol, price, and 7 day of Bitcoin, and I'm stored in a struct. It doesn't say to print it out. I have to do this. But let's say like you want to print this, and there's no way that Rust knows how to print your own personal struct. And there's this shortcut, which is, yeah, like debug, and you can add the debug, and then you can print out a currency. And we just saw this from the helpful like member here, that you can print it out as like a debug formatter. But if you want to do like the display, so like this would work, for example, for like numbers, and this would print out 6, and Rust knows how to print out a number. But Rust doesn't really know how to print out your custom struct. And if you want to have like the display, you have to implement, or like one way of doing it is to implement the display trait. And this you also come across quite often in companies, that you have to implement traits onto your own, on your own custom structs. And this is actually quite simple, since all of this obscure thing, it's just like a standard way of implementing this trait. All your custom stuff is actually just this here. You basically, and like the right, this has to be here, and the formatter has to be passed. and all the rest is up to you. So like you can also just, for example, say Bitcoin, and I know people here have very strong opinions about this stuff, so I don't want to overuse this word. For example, like you can do this, and you can't because, yeah. And then whenever you want to print a currency, and this can also not be Bitcoin, then this would be in every print you print for this type of currency. So, and this little thing is quite good to stumble like against and figure out why can't I just print out my custom type. So like we covered this, and then the question is, but I want to not always have like a fixed amount of currencies I want to deal with. And then like the next step is to build a CLI. And if you think about maybe other, I have 7% left and then the talk is done. Yeah, maybe. Yeah, but this also forces me to be a bit faster. If you, I think I have one, but if you have one too. Yeah, perfect, thank you. Beautiful. Works, nice. Where was I? Oh yeah, like CLI apps. So like you would probably Google CLI app Rust and see like what's up there. And then at some point in your research, you would come across Clap. And this is like another beautiful thing of how easy and fast it is to build a command line application with Rust. To say like the README is always a bit of a scrolling down, and this beta actually broke today my talk, so I have to revert it. But basically we can check out step 5. Does this work? Yep. No, is it step 6? Yep. So here, how a Clap works, or Clap, is you basically give them a few information. You create a new app, and then you can specify arguments. And the next interesting thing is if you want to pass a file, that's one argument, and you pass this. But what if you want to have like a list of like multiple, and then you have to go through like the documentation and figure this stuff out. And I've put this in since a lot of like Rust work in your beginning will be to read through the docs, and Clap has quite nice documentation. So this gives you like a first taste of the ecosystem. And you can say, I want like at least one currency. And then here we already write a CSV file. So it was actually step 5. And then we can skip a few. So here, for example, you can now do cargo run. And then like the next point is how do you actually run this with CLI? And in the beginning, I tried to do like the cargo run, and then I passed the currencies, and then it didn't work. And I had no idea why. And then it turned out that I have to do this, and then it actually works. So here I fetch Bitcoin prices until my API limit is reached, and here. In the next step, we will see how to write a CSV file. This is also quite interesting because this also gives us the option to pass like multiple. So let's say now we have this, and now we go into this stuff where you see, oh, I'm on beta, so I shouldn't be. I changed the version number. It has to work now differently. Oh, all of the stuff is live, and you see of how it feels like. In your docs, like you can choose like the version of like which documentation of the version you want to look. And you see that they changed this in this newer version. And I think this is also different. And then it should compile again. And all of these processes like to work like with the compiler, and now my environment files are not there. You will see like with Rust that you will for 90%, especially in the beginning and later on maybe 70% of the time, fight with the compiler. And this has to come, and it's not a fight, that's a dance. And that's quite nice. And you learn to like the compiler. For me I had my first like the Rust job, and then I had to switch again, I think, to Node.js at the Twilio company. And you suddenly feel that something is missing out of your life. You really feel that how can someone just like write and don't have this compiler? And here, like you see, now we have like a CSV file with the arguments we passed, and this is quite cool. And I feel like this is already so much fun. And later on, in the later steps, if you go through it, you learn more and more until, and I don't go through like the Google Sheet setup, but I want to mention two things. First, I want to show that it actually works. Like I have here this sheet, this example sheet with like crypto and ETFs. And if you go to the last step, you probably need to have the nice, it's already there. So now you can do cargo run. And if you do this and you see this spreadsheet here, that it will be updated, hopefully. Yeah, that's already, I need like a desktop replacement. And you see here, like it's updating like the prices. I have some debugging blocks here, and later on I will fetch here like the sum and this stuff, and send out an email, which should have happened in the logs somewhere. But this is how nice it is, and you can think about maybe like you use like a bug tracker in your company, and you use 3-4 different tools, and you want to, I don't know, collect them and also like let your business people see, I don't know, like what's the current status of the product. And I find that Google Sheets is quite a nice front-end facing database for stuff like this. What's powerful with Rust, I found, is one thing where, for example, now I want to send the email out. And now the question is, and this is quite, or like some nice problems to face, like you have like an email type, but now the question is, should the email type know how to print out the dashboard, or how to print out an ETF, or how to print out like a crypto coin? And like you can say yes, but you can also say no and say the email is just calling a function to HTML on the type and then sends out the email. And for this, like Rust has traits. For example, the email type has a trait HTML with the function to email body. So now I can implement this type, implement HTML for coins to email body, and here I do like an HTML table, and I do the same for the ETFs here. So now the type knows of how to print an HTML body, and the question is now, how do you pass these types to email? And I found this quite nice, and I don't want to spoil this, but maybe I do now. Like, how do you pass an array of different types to a component? And here it's also nice that you basically can create a vector of types which implement this trait. So for example, and here the compiler is nice too. If I would remove this trait from coins, I don't know why it is, and I don't know. Or have to remove it. Eh? Nice, thank you. And now it says, hey, you can't pass this since this is not implementing the HTML trait. And this is beautiful. I like this very much. And then you can say that each of these components have to implement this, and they have to know of how to form an HTML body. It's not up to the email type. And then inside the email, you basically push this to like an HTML string. And on each of these components I pass, so coins.toEmail body, will add to this body string. I return this body string, and then I send out. And this can be done in, I don't know, like a million different ways. But to face these types of problems, it will like lead you down a path which you will face later on, I feel like, in your production environment for like a random company. So like you don't have to make it as complex as this, but it's nice to make it complex as this, because then this leads you down like the good pain path. Like I always say, like there's good pain and bad pain, and good pain, I don't know, like it makes you grow, and bad pain, it's just suffering. And I feel like these types of problems are good pain because they make you grow. And the nice part is here, if you go through the code, it's not super complex. And now you can say, what if you want to use async std? I don't know if this works, like obviously not, but like what if you want to change this? What would break and why? Or your colleague says, we don't want to use clap, we want to use something else. They will probably never say this to you, but let's say like you don't want to use, yeah, like request, but something else. What if, and I use like a logging library here called log4rs. And what if you want to try like a new logging library in your production system at work? This is the perfect playground to try this out and see it in production, and then see of how it feels like. So not to make it too long, feel free. Oh yeah, and this compiling. I just spoiled this like real quick. Like if you want to cross compile, you have to prepare your host setup in a certain way. I think I also link to a really old blog post, but which basically like explains like what you have to do. You can add a target to your Rust up tool chain like this. And then later on, like once you've done this, and I think I didn't do this here, you can do release and then target. I don't actually know target, and then you do this here. And then your host, and this doesn't work since I didn't add it yet. Oh, Jesus, like what is cargo? This is embarrassing. Cargo build. Thank you so much. Yeah, this doesn't work since it's not a setup here on my Mac. But then you can basically build a binary which is aesthetically linked to, I think it's libc, and then you can push it to like a random Linux server, and it runs there. So this tutorial will lead you down this path. You might not have to follow this whole path. For example, you can try different, like refactoring stuff. You can, instead of storing it in Google Sheets, try out different databases. And if like finance is not like your jam, try to collect information and send you out emails. Like it was quite nice, since after like 1 or 2 weeks, I forgot that I wrote this job, and then I was on Sunday on my couch and got an email from my own application with information about my stuff, which is quite nice. And I feel like this is quite nice to have like a running like Rust application in production for yourself to learn stuff. Okay, that's it. Thank you for listening. Are any questions? No. Okay. No questions. Thank you. I think there's a break now. Is there a break now? Yeah, there's a break now. Okay, I'll see you in 5-10 minutes. Yeah.
For the async to be made, we need to enable the attribute.
1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Excellent. On which you can find me on GitHub, Discord, RC, Matrix is Wadorowski, and I'm going to talk about developing and managing eBPF programs with Rust. So a bit about me, my pronouns are he, him, or they, them. I work at SUSE, and my background before coming to Rust was mostly Python and OpenStack, and afterwards Golang and Kubernetes. And mostly, nowadays I use Rust, Go sometimes still and C, and I still mostly work with Kubernetes and container-related topics, and sometimes with Linux kernel, and of course a lot of with BPF. I will start with the short introduction. What is eBPF? And eBPF is a mechanism in Linux kernel which allows to inject programs which are triggered by various events or integration points in the kernel. And one of the most popular triggers for BPF programs in Linux kernel is network I/O. And there is, well, the most known projects which is using eBPF it's called Cilium is using it, for example. There are also a lot of projects which are using eBPF for tracing functions both in the kernel and in the user space. And yeah, like tracing some function calls is also an event, a trigger, which BPF program can be triggered by. And the last thing I'm mentioning here, for me, very interesting one, are LSM hooks. And LSM hooks are custom hooks in the kernel code, which allow to create a security system which is denying or allowing some action. And if you know SE Linux and AppArmor, for example, these two security systems are in fact using LSM hooks. But nowadays, since kernel 5.7, you can use those LSM hooks also for creating BPF programs. So you can, in fact, try to create your own security system similar to, let's say, SE Linux or AppArmor by writing your own BPF programs and not doing any change to the upstream kernel source code. And BPF programs are, at the end, compared to the bytecode. You can also write BPF assembly, but for example, I've never done it. Mostly, people write BPF programs in C, and then the C source code gets compiled to the BPF bytecode by LLVM. But nowadays, there is also a similar possibility of doing it from Rust. Since Rust underneath also uses LLVM. So at the end, LLVM is still used to convert the Rust code into BPF code. Although I'll come to that later, but yeah, the BPF programs are supported in Rust, but it's still super early, super experimental. There is not yet any project which would be used on production, which is developing BPF programs in Rust. Yeah, like in the most known projects, it's still done with C. Well, some sorts of BPF programs are like tracing events or getting information about events, and some of them can make actual decisions, what's happening with some events happening in the kernel. And well, I mentioned that probably the most popular kind of BPF programs are the network ones. And in case of network BPF programs, you receive the events from the kernel that some packet came to the network card, or there is a packet which was parsed by the kernel. And in that case, you can make an actual decision whether you allow that packet to come, whether you redirect it somewhere else to some other network interface, or maybe you just want to deny it and not come to the down, go further anymore. But the other interesting kind of BPF programs which allows you to make decisions is, as I mentioned, like LSM BPF programs. And LSM hooks are very various. You have like a bunch of LSM hooks triggered by I/O. You have LSM hooks triggered by creating a new process, someone trying to log in as some user. They are really various, and to all of them you can write a BPF program in which you make a decision whether you want the particular action to happen or you are going to deny it. And well, when you use BPF, you write BPF programs, and then you need to write a user space program which is loading BPF programs into the kernel. And loading of those BPF programs is done by BPF system call. So yeah, usually when your project consists of two parts, and yeah, one is set of BPF programs which are usually compared to ELF objects, and then you have user space part which is loading them into the kernel. And BPF has a concept of BPF maps. They are data structures in which BPF programs can store the data, and those BPF maps can be also shared to the user space. And there's a directory sysfs BPF in which you can pin those maps and let user space programs to interact with them. And well, I will start with showing how BPF programs look in pure C before going to the Rust examples. So I will most likely have to increase the font, right? So okay, yeah. Yeah, the example in C is here. So we have a very simple BPF program. Oh, yes, like that. Okay, so it's a very simple BPF program. Why are Discord notifications popping up? I don't know. It should be turned off. Okay, I hope they will be gone right now. But anyway, so there in kernel there is a function called clone, which is called every time we are creating a new process. So basically, when we are doing fork in the user space in the kernel, we end up with the clone function being called. And we have here fentry type of BPF program, which is tracing some function when we are entering it. So at the moment of call. So this BPF program is attaching to the clone, kernel clone function. So it's getting triggered every time when we start scheduling some new process. And in this program, I'm only getting the PID of the process scheduling the new one, writing that PID in a BPF map, and logging the fact that something like that happens by BPF print K. And this structure here is a BPF map in which I'm storing PIDs, and here I'm making an action of saving the particular PID into that BPF map. And here I'm getting the name of the process. So com is like a name of the process in the kernel, and yeah, here is just logging. And there is a user space part, which is loading that BPF program. LibBPF, so the library in C, which in which you are writing both BPF programs and loaders, has a concept of skeletons. They are auto-generated, so that header is auto-generated. You instantiate that skeleton, attach the BPF program, and then to keep the program alive, a BPF program alive, you have two ways. You can either keep the user space program alive, and as long as the user space program is alive and we don't catch any signal here, the BPF program is alive. But if we want to keep the BPF program alive even after our loader is not alive anymore, we need to pin the program in the BPF file system. Yeah, here I don't have an example for that. In this example, the BPF program is dying immediately when the user space component is gone. So I'll run. Let me run it. Yes, I will end here as well. Like this is fine. Okay, so yeah, I have 3 examples already here, but I will go to the one in C. I will compile it. Oh yeah, it's already compiled. And yeah, just to show it, I will remove the output and compile it again. And important thing is that to do anything with BPF programs, you have to be root. So we need to execute the fork trace, because that's the name of our program, is roots. Successfully started, and now in the other terminal we can use the tool called BPF tool to check whether the program is really running. And we see it here. We have a tracing kind of BPF program whose name is kernel clone. And we can check the logs of BPF programs by doing BPF tool proc trace. And here we should see our output that, yeah, some process is forking. So we have bash forking, we have cron forking, xdg, dbus proxy, and other processes doing forks. And we are also saving the PIDs in a BPF map. So we can look up for BPF maps. We have only one BPF map in the system, which is called processes, so it's ours. And we can dump the map by name processes. And yeah, we have PIDs. I was in the program, I was assigning value 0. I was interested only in storing PIDs as the key. So here it is, the proof that it works. And yeah, the presentation is mostly about Rust support. I showed how it works in C as the reference point. But there are 2 ways and 2 separate libraries in Rust which deal with BPF. The first one, the more popular one, and in fact official, because it's like affiliated with libbpf, is literally like libbpf/libbpf rs on GitHub. So it has pretty much the full coverage of BPF features and BPF programs. But the thing is that when using libbpf rs, only loader user space part is written in Rust. BPF programs themselves are still written in C. So when you are using libbpf rs, you maintain both C part of code for the doing stuff in the kernel and the Rust part for loading and managing. But there is also more experimental library which allows you to do both things in Rust, which is called Aya. It's really cool, it's really promising, but not every type of BPF program is supported yet. And yeah, it still requires nightly Rust. And I'll start with showing example of libbpf rs, where so in case of libbpf rs, the BPF program is still the same in C. It's even assembling here in this example, but we have a main rs module, which is using libbpf rs to load the program. Whoa. What happened here? Okay, now it works. All right, so yeah. So libbpf rs automatically generates a skeleton from the C source, so that fork trace scale builder is a structure which was automatically generated from that C code. And yeah, you open the skeleton, you load it, and then you have that skeleton is providing mutable references to all the BPF programs in the particular module. Here we have only one, so we are just picking the kernel clone from proxmood. We attach that program, we attach the link, and yeah, after that line, the program is loaded and it's going to be kept alive as long as the user space process is going on. And yeah, here is just code for like handling signals and like showing dots as long as the program is running. So yeah, let's check this out. I will go to the upper directory and libbpf rs example. Here we have it. I will show how is it building, and there is a custom like cargo extension which we are going to use with libbpf rs. So we will do cargo libbpf. So there is a libbpf cargo module, and by doing cargo libbpf make, we are firstly building that skeleton from the C code of BPF program, and then we are building that main rs program. So it's doing it by two steps, compiling BPF objects and like generating that skeleton, and now we are actually using like the main cargo for compiling everything. It will take some time. All right, so it's here, and now we should have the ready to go binary, which we can spawn in target, debug, fork trace. That should be it. Yes, and it's it. So let's check out what BPF programs are loading. And yeah, we have that tracing program, and we have also maps, and we can dump the map again. And yeah, we have a bunch of PIDs. Yeah, it's a bit shorter because I made it faster right now. So, and yeah, we can also check the logs. So BPF prog trace. Yeah, so we have like a bunch of forking processes. And some new ones which just came up. So yeah, pretty much the same experience, but the loader is in Rust. But now I'll show the example of Aya, which in which program the actual BPF program is different. Ooh. So here I have a bunch of subdirectories. The project tree here under Aya directory is auto-generated. They have a template which creates those 3 subdirectories. I didn't use the example common though. It's like just a boilerplate if you want to have some common library for something. But the 2 most important subdirectories are Aya example, which is our user space program, loading the BPF program, and here the actual BPF program, which is getting loaded. And the source code of the BPF program, as you can see, is in Rust. So it's doing the similar thing as the C code you've seen before, but yeah, we have a definition of map here, to which we are writing the PIDs. We have the common practice in Aya is that you write the main program just like as that one match unsafe thingy, and then you have separate unsafe function where you actually do stuff, because BPF programs, they will be always in unsafe context. So yeah, that's because of that. And yeah, in that BPF program, we are getting the PID. We are writing a log, and then inserting the PID into a BPF map. Yeah, we need to have, in case of BPF programs written in Aya, you also need a separate panic handler, which you always assume that it's unreachable. And the loader part looks like it's loading slow. Come on. All right. And yeah, the cool thing about Aya, that feature just came, I think, like 3 days ago, is that it has like the Aya log sublibrary, which is showing you the logs of BPF programs in your loader, and it's using underneath the perf event array, but yeah, it's doing it's automatically for you. It provides simple logging, which yeah, we will see later. And here is the initialization of it. Here we load the BPF program. And here we are getting the mutable reference to our particular program we are interested in, which is kernel clone. We then attach it to the kernel clone function. And yeah, here it's just like, yeah, signal handling and showing dots that it's running. So yeah, let's check this out, how it works. Well, similar to the other examples I showed, but yeah, it's all Rust. So yeah, let's remove target. And here we have 2 commands. So we have an xtask to build the BPF program first. So let's do that. Ooh. Cargo xtask build eBPF. It's taking some time. And yes, I mentioned it's using the internal LLVM inside Rust compiler. And yeah, now we can build the loader, which is you know, just with cargo. And yeah, as you can see, the user space part here is yeah asynchronous. It's handled by Tokyo. And okay, we have it right now. So as a root, we are spawning the loader. It's in debug example. And then as an argument, we provide the BPF program to load, which is under target BPF unknown debug and example. Okay, so yes. So it's running, it's showing some logs here. And yeah, let's check the content of the BPF map then. The situation should be pretty much the same. So we are going to have a hash map with processes. And we have two new BPF maps. That's internal stuff handled by Aya to show you the logs here in the output of user space program. So these two come from internal Aya sublibrary. And let's dump processes. Here the output is a bit different because it's still in hex. It's in the hex format, but this should be pretty much like the same PIDs, similar PIDs to which we are seeing in the PPF programmers in C. And yeah, of course, value is 0 because we always assign 0 here. We just assign the PID as a key. Funny thing, AI is still super experimental, and the reason why the log message is only some process forked is that when I tried to log the actual PID, the program was crashing. So yeah, that's how experimental AI still is. There are definitely some bugs. But yeah, at least I managed to save PIDs in a BPF map, so that part worked. But logging it was not possible. All right. And okay, that was it when it comes to libraries in Rust for handling and writing BPF programs. Now I wanted to just tell a bit about the project I'm working recently. So I'm working also on quite fresh and experimental project called Loxy, which is trying to use eBPF LSM type of programs to make containers more secure. There is a phrase about containers, containers do not contain, and that phrase means that contrary to popular belief, containers are not as secure as VMs, and they expose a lot of stuff from the host. And yeah, you can question whether it's necessary or not. But well, there are 2 points which are more important and like most frightening about containers today. Some file systems are not namespaced. So okay, like when you create a container, you have some rootfs image of some other Linux distribution, cool. But some contents of /sys and some contents of /proc is the same. And to the degree that if you go into sys btrfs, for example, inside container, when you are using btrfs as the file system on your host, then you are able to look up for metadata of your host partition. When you are in a privileged container, you can normally use fdisk. You can see devices, you can see proc IRQ and stuff like that. And yeah, in my opinion, it's not really necessary. I would rather like the most of those subdirectories to be hidden from the inside container. So that's the one point which Loxy is going to tackle. The second point is that Docker, by default, without any plugins, allows you to mount everything inside container. And it includes also your / directory from the host and Docker socket. And if you mount those inside the container, then yeah, you have pretty much passwordless sudo. And now combine it with the fact that usually in the most Docker installations, you have a Docker group and you add regular users to the Docker group so they can run containers. So even though someone is a regular user, with sudo with password. He has granted for free passwordless sudo because he can just type docker run -v/ or mount the Docker sock. Yeah, it's possible. It's also possible to do chroots inside containers. So yeah, the goal of Loxy will be providing some kind of policies to prevent regular users from doing such actions. Yeah, the goal of this talk is not to go too deep into that project itself. Feel free to. I would be happy if you check out this project. But yeah, for now it's using libBPF RS because AI is lacking a support for LSM type of programs. But as soon as AI gets that support, I'm trying to work on that right now. I will be more than happy to rewrite everything in Rust and keep everything in Rust, not bother with C. So yeah, that was all from me in this talk. Thanks for listening. I hope you liked it. And yeah, do you have any questions?
Questions? Yeah, the person in the room.
How do eBPF programs written in Rust and C compare in size? For example, when you compiled that BPF program with Aya, I saw it compiled like the core library of Rust and so on. So I guess that's statically included. So how big are these things and how does it compare between Rust and C?
Rust one is bigger, yes. It takes longer to compile also, and it statically links some parts of LLVM. So some parts of LLVM core library. So yes, the Rust BPF program is bigger.
Thank you for the presentation. So in the Aya example that you showed, you mentioned that the Rust code had to be explicitly marked as unsafe. Is it because it links against libBPF, or what is the requirement that Aya has that makes Rust code unsafe?
The thing is that BPF programs get the arguments from the kernel. So when we go to our program here, that context, you get it from the kernel, and that context contains a lot of pointers which point to the memory which kernel allocated, and not Rust runtime. So yeah, that's because of dealing with pointers which we received from the kernel, and we have no idea like which size are these, and yeah. So that's because of, yeah, we didn't handle that memory allocation ourselves here.
So you mentioned that eBPF programs are written in a bytecode, and I also noticed that they're loaded into ELF files. And I was wondering if you'd go into detail about what the bytecode is and why it's in an ELF file.
Much knowledge about that, about such a low-level part of it. So yeah, I'm worried I will be not able to provide any like meaningful answers here. But yeah, usually the output of like compilation of BPF program by LLVM is like the O file, which has ELF sections, which has like the BPF program itself in a separate section, maps in separate sections, and yeah, then it's getting loaded by libBPF into the kernel, and libBPF is also aware of like the ELF structure of it. I'm sorry, I'm not able to provide any more detailed answer than that.
Well, neither could I. So there's something to do with security. I was remembering that you don't have everything allowed in eBPF because it's in secure context. So the bytecode doesn't allow everything that C would allow you to do in that context. So you can't break things so much in the kernel.
Yeah, that's true. Yeah, and in BPF, inside the kernel, there's also a verifier. So when that bytecode is loaded into the kernel, it's not executed immediately, but first the verifier is checking whether you're, for example, not reaching the bounds of memory which kernel allocated for you. So it's firstly isolating, analyzing the whole bytecode, and when the verifier says, okay, that bytecode is safe, and okay, I can execute it without leaking memory, then it's executed.
So I didn't know about BPF before, and I just wanted to ask. I don't know if it's even right in the context, but is it constrained to any kernel version or like recent kernel versions?
Depends on the type of program. In general, eBPF, as we know it, started being available around like 4 point something. I would say like the oldest kernel which you can run to support the oldest type of network programs, for example, be able to use Cilium is like, I would say 4.18. You shouldn't go older than that. But then the more types of BPF programs started coming, they were coming in newer versions of the kernel. And for example, the LSM type of program, so the one which I'm using in Loxy came in kernel 5.7. So it differs on the type of program. The cool thing about BPF2 is that it provides probes, so it can list you what it checks your kernel, and it provides a list of what kind of BPF programs are supported, what kind of BPF maps are supported, and it also lists functions which you can use in BPF programs. So there is tooling around like checking what can be done with your kernel. But yeah, definitely the newer type of BPF program there are more constraints about new versions. And if you want to use the newest stuff from like last year, then I would say like 5 point something, 5.7 is necessary. But if you are dealing with networking, like tracing packets, redirecting them, doing some firewalling, DDoS protection, 4.18 should be fine.
And one for the picture. Okay, thank you. So you mentioned your personal project, Loxy. I also assume that you know App Armor from Google. So how is it different, any different from App Armor?
So Loxy is aware of Inch container which is running, and it's designed only for containers. And so far, my idea is to have 3 different policy levels for containers: restricted, baseline, and privileged. Where privileged will be really the kind of policy which could be applied only by root, and it will be discouraged to use it for anything else which is not Kubernetes infra, so like CNI plugins, Istio, service mesh, or whatever. The baseline and restricted will be like the most encouraged to use, and also able to be picked by regular users of Docker or Kubernetes. The difference is that, well, in AppArmor and SELinux, for example, in regards to mounting files into the container, from my knowledge, there is not really a way to differentiate what you can mount to each particular container. You are rather globally labeling directories which you can, in general, mount to the container. For example, in case of SELinux, you apply a label to some particular directory which you want to mount, but there is no differentiation or limitation to which particular container you can mount it. So there is not so much awareness about particular containers running. And on the other hand, in Loxy, I'm maintaining the BPF map containing all the containers running, then all the processes belonging on them. So when I get the event coming from some particular process, I'm able to look up for a concrete container and decide based on that what to do. And there is not so much awareness about particular containers in terms in AppArmor, SLinux, or SMAC, or any other LSM system.
No questions. Okay. Thank you so much for this talk. And thank you all for joining. I have no idea yet when the next meetup will be. We will see. You will see it on meetup.com, like maybe next month, maybe 2 months. Who knows? But I try to do it soon. Okay. Have a good trip home. Thank you.
Thank you so much.